A warm welcome to all. In this video, we'll be discussing the chemical composition of cellulose. In our previous videos, we have discussed the different techniques used, the chemical techniques used for elucidation of a structure. Now, as an example, we'll be taking cellulose and we'll decide how to determine the structure of the cellulose using those chemical processes. Now, when we say cellulose is a colorless solid insoluble in water and usual organic solvents like ether is there, alcohols are there. So it is not soluble in usual organic solvents, and it is also not soluble in water, but it is highly soluble in Chevreul's reagent that was made by a Swiss scientist, and that is actually used for isolation of the cellulose. So what is Chevreul's reagent? The Chevreul's reagent is ammoniacal cupric hydroxide solution, and when it is dissolved, when the cellulose is dissolved in it, it forms a complex in that molecule in this solution. So starch is also soluble in strong acids, that is hydrochloric acid. But the problem with this is that when we are dissolving it in hydrochloric acid, it degrades the molecule, and the low molecular weight cellulose these byproducts are obtained. So we will get the different fractions of the cellulose with low molecular weight. Cellulose is of three types. Generally, it can be alpha, it can be beta, or a gamma cellulose. When we say alpha, alpha is basically undegraded, that is complete raw cellulose. We say undegraded when we are extracting it from the pulp. It is undegraded and high molecular weight cellulose, that is an alpha. And the main character of alpha is that it is dissolved in dilute HCl, dilute acid, and it is insoluble in aqueous sodium hydroxide, 17.5% of aqueous sodium hydroxide. Then we have another class of cellulose, that is beta cellulose. Beta cellulose is usually the one that is degraded. If we are degrading, then the main raw cellulose is degraded, it is forms the low molecular weight cellulose, and that the character of that degraded cellulose or beta cellulose is that it is soluble in 17.5% aqueous sodium hydroxide and is insoluble in dilute acetic acid. Then we have another one, that is gamma cellulose, that is mainly hemicellulose and is mainly insoluble in both 17.5% aqueous sodium hydroxide and in dilute acid. Now, to know the structure of the cellulose, as we have discussed in our previous video, that there are various ways to illustrate the structure of the polysaccharides, and now in this case we are taking the example of cellulose. So first, for using the basic analytical techniques, we get that cellulose is having a formula of C6H10O5 whole N, where N is the number of times the unit is repeated here in the cellulose. So we say that it is analytical data, it is molecular formula will be N times C6H10O5. And then hydrolysis is the important thing which is used for elucidating the structure so of polysaccharides. And in this case, when cellulose is hydrolyzed using HCl, hydrochloric acid, dilute HCl, it has been found that D-glucose is the main product, and this D-glucose has been obtained as 98%. So this 98% indicates that the D-glucose is main constituent of the cellulose. So cellulose is made up of monosaccharide units, that is D-glucose monosaccharide units, and around 98% of the D-glucose is present in cellulose. 98% of the glucose units are present in the cellulose. When the structure has been further elucidated when we are doing the methylation, acetylation, and nitration. In case of whenever the cellulose has been methylated, whenever the cellulose has been nitration, and when there was an acetylation, it has been found that tri-substituted products have been obtained. So what does it mean? We know that the free hydroxy groups, when treated with the methylating agent, as we know, that's methyl iodide in presence of a base, or we have uh, um, we have dimethyl sulfuric acid CH3 whole 2 SO4, and we also have methyl iodide in presence of barium oxide, that is the Srivastava et al. That has been obtained in 1963. The method, and which has been found mostly useful in case of the polysaccharides, barium oxide in DMSO. So when any of the methods, when we are using the methylation method, it has been found that this hydroxy group has been converted into OCH3. Now, it has been found, estimated that all the three hydroxy groups have been converted into OCH. So that is why we write the word tri-substituted. So what does it mean? That each monosaccharide unit which is present in cellulose is having at least three pre-hydroxy groups, pre-OH groups. So we can say that in each acid, in each these sugar molecules, we have at least 4 to 5 hydroxy groups. We have 5 hydroxy groups, and we say out of the 5, 3 are free hydroxy groups. And uh, the same has been found when acetylation has been done. Acetylation, that is using the acetic anhydride CH3 CO whole twice O, and in presence of H2SO4. Again, it has been found that the tri-substituted product has been obtained. That is, the free OH which is present there has been converted into OAC. So again, it has been proved that there are at least 3 free hydroxy groups which are present, and the similar has been obtained by nitration when the cellulose has been treated with nitric acid and sulfuric acid. So it has been found again that tri-substituted product has been obtained. So the first one where we can say that there are at least that is the presence of glucose molecule. So we say that glucose molecule which is having 2 3 4 5 2 3 4 and 6. If it is in pyranose form, then it is 2 3 4 and 6 hydroxy glucose. So out of these 4, 3 are free, and if it is having, if it is in a normal D glucose molecule, we can say that it is having 2 3 4 5 and 4 5 and 6 hydroxy. So in that case, if it is not in a pyranose, if it is an open chain form, then we can say that out of these the 3 are free. So usually when we say that in polysaccharides they are in the pyranose form or furanose form, so we can have 2 3 5 4 and 6, 2 3 4 and 6 hydroxy. So out of these there are only 3 which are free and the one which is attached. So we can say that this gives us an idea of how many hydroxy groups are free in it. Now to confirm the structure further, the methylated cellulose that was obtained in the previous slide, this methylated cellulose is further hydrolyzed using the acid hydrolysis, that is HCl. When hydrogen chloride has been used, dilute HCl has been used, we are obtaining the two products. One has been found as 236 tri O methyl D glucose, and another is 2346 tetra O methyl D glucose. And the percentage of the two, that is an important thing to note down here, that it is around 90% and 0.6%. So we say that the methylated cellulose, when treated, the first thing is like there might be the presence of when we say that when we are using the free methylated groups which are present, if it is in pyranose form, it is like this. So we have 2 3, sorry, this one is OH, carbon 1 2. So this one is OCH3. Then it has been obtained again, OCH3, 2, 3 and 6. So this OCH3. Now in this molecule we can say that this is 2, 3 and 6 trimethyl triomethyl D glucose. So that has been obtained at 90%. So we can see that this hydroxy group is free here at the carbon 1, and we have a free hydroxy group at the carbon 5. So it is possible that there is a linkage. The two glucose units which are connected in cellulose, they have a linkage through this carbon 1 and this carbon 4. Carbon 4. So this one is carbon 5 and this is carbon 6. But it is possible if it is in the form of a pyronase, that is a 6-membered ring. If the same unit is present in the form of a 5-membered ring, that is furanose form is there. So we can have like this. We have 2 OCH3, 3, and then we have 6 OCH3. So in this case, we can say that since we don't have the 4 position available here, there is the position available is 5. So from this, it is clear that either it is having a 1,4 linkage or a 1,5 linkage. In this case, it will be the carbon 5. So the linkage is through the carbon 1 and the carbon 4, or the linkage is through the carbon 1 and carbon 5. Now, the important thing is that how to know whether it is in the process of 6-membered ring, that it is a pyranose form, or it is a furanose form, that is a furanose form 5-membered ring, or it is a pyranose form, that is a 6-membered ring. So it is easy because we know that when we are doing the hydrolysis, and if it is easily hydrolyzed, we say it is furanose form, and if it is not easily or readily hydrolyzed, then we say that it is a pyranose form. So from hydrolysis itself, we are having one more concept. Based on the basis of the hydrolysis, we can decide that the ring actually is the 1,4 linkage. So we say that it is the 1,4 linkage which is present in the cellulose. So we are having an idea that the cellulose is having glucose molecules, and these glucose molecules are connected through 1,4 linkages. So from these two experiments, we are getting this from the hydrolysis, and from the hydrolysis as well as from the other when we are doing the methylation, when we are doing the acetylation, or when we are doing the nitration, and when we are using the methylated cellulose. From these three experiments, we are getting the information that it is quite possible that it is a pyranose form. First, second, the pyranose form, it is connected because we can see that when we are using the methylated, this compound is the carbon 2, it is having methyl group, that is it was the group which was free here. If it is a pyranose form, so we say that it was free, it was not linked, and that has been converted into a methyl group, a methoxy group. Then carbon 3, so we say that this carbon was again free. Then we say that carbon 4, this carbon 4 is having an hydroxy group, and carbon 5 is also having an hydroxy group. So this carbon, the hydroxy group at carbon 5, it is actually basically the pyranose that forms a ring with this carbon that forms a ring. So we say that this is not free, it was in the ring, and because of the hydrolysis we are getting this hydroxy group. So the free hydroxy group here was carbon at the carbon 4. So we say, and then the carbon 6 which was free in the main structure, it is also methylated. So we say that actually the carbon 2, carbon 3 and carbon 6, they are having free hydroxy groups in the cellulose. And when we say the structure, we say that actually the carbon 5 which is involved in the pyranose ring formation, and the carbon 4 which is free, it is the linkage should be between the carbon 1 and carbon 4. So this gives us an idea about that linkage. Then let us come for the aldehyde, the second product, which is 2,3,4,6 tetra o methyl D glucose. Whenever we are saying that they are having the chain structures, or polymers, we say all of the polymers are having a non-reducing side and a reducing side, a reducing end. The reducing end is where we have a ring like pyranose ring like this, we have the anomeric carbon, that is free carbon. So this forms the reducing end because this converts into an aldehyde, converts into an CHO. And then we have having a non-reducing side. Again, in non-reducing side, we will have four free hydroxy groups, and that four free hydroxy groups will be converted into the free hydroxy groups. They will be converted into methyl groups. So in this case, we can say that there is a one methoxy group, methyl group, which is present at carbon 4. This also indicates that in the remaining ones, the carbon 4 is actually attached, uh, linked, and in the non-reduced this end at the non-reducing it is a free one. So in non-reducing one, it is only the carbon 1 which is linked, and the carbon 4 is free. So now when we say the another one, that is 0.6%. This 0.6, the first thing is like we are getting only two products. We are not getting the third product. We are not getting a di-substituted product. If there is a dimethyl D-glucose formed, we could have said that the molecule is having a branched structure. It is having a chain, branched chain structure, branched chain. So from here, we confirm that the molecule is linear because, as in my previous video, lecture, I have already said that if it is having 1 2 1 3 1 4 and 1 6 type of linkages, in that case we say that they are linear molecules. And had there been any other linkage, that is the point, chain point, then we would have said that there might be the possibility of getting dimethyl D glucose. For example, if there was a chain at carbon 4 is already carbon 3, it makes a branch, then that would have been involved in the branch formation, and we couldn't get the we could have obtained only a di substitute, that is 2 and a 6 di substituted methyl dimethyl glucose, methyl D glucose. But hence, since there is absence of dimethyl D glucose, we say the glucose molecules which are arranged in cellulose, they are linear. They are arranged in a linear chain structure. So this gives us an information about the linear chain structure. Now the third point is when we are concerned with the percentage, when we say that it is 90% and 0.6%, as I said that this will be the non-reducing end, which will give us the molecule like this, and the reducing end will be lost, and then the remaining ones, they will be formed because they will have two linkages. And as we have decided now, it will be the 1,4, it is the 1,4 linkage. So the non-reducing end will give us this. So the 0.6% means that around 100 to 200 glucose molecules are present in the cellulose. That is when it will form the one molecule, that is the non-reducing end, which is present at the non-reducing end. It will form only 0.6%, around 0.6%. It is more than 100 molecules, because in 100 molecule, one also indicates the 1%. If in 100 molecule there is one at non-reducing side is 1, if it is 1, we can say minimum 100. Since it is 0.6, it can be more than 100, and we can say that it is 100 to 200%, 200 glucose units which have been attached together. So this, all this information, this gives us an information about the tentative structure of the molecule. When we say the tentative structure, we can say that in tentative structure, now we say each, suppose this is one glucose unit which is present in the um, cellulose. We say that this cellulose is connected from one side. On one side, it is connecting using its carbon 1, and on the other side it is using its carbon 4. You can see that carbon 4 is again linked. Then we say that the carbon 5, which is also free, we are getting free, that carbon 5 is used actually in the formation of a pyranose ring. And we are having three hydroxy groups free, OH, one at carbon 6, one at carbon 3, and one at carbon 2. These three hydroxy groups are converted into, when we are using the dimethyl sulfuric acid for methylation, and we are getting the product, that is methylated glucose. And here methylated D glucose, that is 2 3 6 trimethyl D glucose, 2,3,6 trimethyl D glucose. And when we are further hydrolyzing this molecule, there is the hydrolysis of, this is glycosidic linkages, and this glycosidic linkages, you can say that we are having a hydroxy group that is free at carbon 1, and a hydroxy group that is free at carbon 4. So this confirms that there is a 1,4 linkage in the present in cellulose, where the glucose molecules are connected through one glucose molecule connects through linkage 1 with one monosaccharide unit, and with it connects through carbon 4 with another monosaccharide unit. Now, so this is a tentative structure. In this structure, we have an idea that how they have been linked, but this does not give you an idea that whether these linkages they are alpha in nature or they are beta in nature. That is important thing is to know whether the linkages which are involved in them, whether they are alpha in nature, whether they are beta in nature. However, we have an idea that the structure of the molecule it is having a linear chain, and we from these experiments we also know that now the glucose is the main component of this glucose is the main component which is present in these molecules. Now, another experiment that has been done to know the structure of the cellulose, that was acetylysis. Acetylysis is a process in which we are doing the acetylation followed by or the simultaneous acetylation and the hydrolysis using H2SO4. So we are doing the acetylation using the CH acetic anhydride, and we are doing the acetylation, the hydrolysis simultaneously using the sulfuric acid. When cellulose has been subjected to acetylysis, there is the formation of cellobiose. Cellobiose is a known structure. It is an established. Cellobiose has an established structure. We say that it is a disaccharide, which is formed by two glucose molecules which are connected glucose molecules, and they are having 1,4 linkages, and the nature of linkage present here is beta. So from this formation of cellobiose we can say that now we already know that it is that cellulose is made up of glucose. We already know that it is having 1,4 linkage, but from this we can say that it is having the beta linkages are present. Now the question is that whether it is only the beta linkage or somewhere it is alpha linkage, or there may be the presence of alternative alpha and beta linkage, and maybe the alpha linkage is getting uh, hydrolyzed and we are getting only the beta linkage in cellobiose units. So to confirm it, it was a limited more careful electrolysis was done, and some additional products were obtained, and that was cellotriose, cellotetraose, and cellopentose. When confirmed, when it was decided discussed the structure of cellotriose or cellotetraose, we say that cellotetraose is having 4 glucose units and cellotriose is having 3 glucose units, and it was also they were obtained the 5 glucose units, that was cellopentose. It in all these it has been found that there is only the beta linkage. You can say that if you say that this is above the plane, it looks like above the plane and it is beta, but you have to see that the oxygen, the position of oxygen in the ring, and as per that ring we can say again that this is a beta linkage. So in all, so we can say that it is not alternate. If it is an alternate, then it would have been like this one should be an alpha linkage, or in the 4 one, when we are having the 4 member or 5 member, we always say that they are all the beta linkages here. We are now, so this confirms that even in the uh, cellopentose we are found that there are 4 beta linkages present. From this we can say that no, the this cellulose molecule, it is having 1,4 linkage, that is confirmed now. It is having glucose, that is also confirmed. D glucose molecules are present, and now we also that these linkages are beta in nature, because the cellobiose or the cellotriose or the cellotetrose, which we have, and cellopentose, which we have obtained from the electrolysis, that is the simultaneous acetylation for and the cell and hydrolysis with using H2SO4, we are getting the this knowledge that now the cellulose is the structure of cellulose is confirmed. However, to know whether it is actually the linear structure or not, we have done some more experiments, some physical parameters have been checked. So that was further established by the fact that they are having the linear structure. It was established by the fact that the colloidal solutions have been obtained when it was dissolved. The colloidal solutions have been obtained when the cellulose was dissolved in the solvent in which glucose is soluble. Glucose is soluble in acetic acid, glucose is soluble in water and some other solvents. It is soluble in acetic acid, it is soluble in 80% alcohol. So 70% alcohol, 60% alcohol. So when these solvents have been used, it has been found that the colloidal solution has been obtained. Had it be that the cellulose has a branched structure, not a linear structure. In case of branched structure, it was quite possible that there will be in the formation of suspension has been obtained. Since we say that there is a colloidal solution, this colloidal solution is because it is quite possible for a linear structure to produce the linear colloids or to produce the cyclic colloids or spherical colloids. So the shape, it would have been easy for the linear to form a colloidal solution. So this is one that we say these molecules are having the colloidal, the molecule is having a linear structure. Then second, it was the formation of fibers such as rayon. These are the byproducts when they have been synthesized, and it has again formed that they are linear. Then third, it was the X-ray analysis that has given us the idea about the the structure of the molecule, whether the molecule is having chain linear structure, it is a linear chain or it is a branch chain. From X-ray analysis, it has been found that though it is a three-dimensional structure that we will discuss in next slide, it has been found that through X-ray analysis also it has been found that these are linear molecules. And then again, an important thing that we have already discussed, that is the dimethyl glucose is absent. Since when we are doing the hydrolysis, had it be that there was one or two or three molecules of 3% or 1% or 2% of O methyl glucose obtained in this, we could have easily understood that there was a branched point present. But since there is no di substituted product has been obtained, so we say that the molecule is not branched, it is a linear shape. So based on these assumptions, the experiments, we say that the structure of cellulose is like this. In this, we can say that, as we discussed, that is the non-reducing end. That non-reducing end is where we are getting the four substituted methyl, tetramethyl. One hydroxy group, we are getting the hydroxy group here, we are having the hydroxy group here, and we are having the hydroxy. So that is why we are getting 2 3 4 6 tetra o methyl d glucose. That was around 0.6% on hydrolysis. And this reducing side, definitely it is also having the 4 hydroxyl groups, but when we are doing the acid hydrolysis, this will be decomposed. There will be there the molecule, not this one, it will show here that is an anomeric carbon, and this will be reduced, and this will be oxidized, it will form an aldehyde. That is why it will act as reducing agent. So we are getting only 0.6% because of this. And then we say that it is having a repeated cellobiose unitus, and we say that there is the value n, that means number of cellobiose units which are present in this, or the number of glucose units. As we said previously, by taking the fact that only 0.6% of this one has been produced, we say around 100 to 200 units will combine, that is 100 to 200 glucose units, or you can say around 100 cellobiose units, or 50 to 100 cellulobiose units will combine to form the cellulose. So this gives us the structure of the cellulose. Now the important thing is, like, now we already know that glucose is the main constituent. Then we know that 1,4 linkages are present. That is another important factor. Then we know that the linkage, the type of linkage is beta, and we know that the linear structure, it is having a linear structure, that have been confirmed. Now the important thing which is missing is the molecular weight. So we have to decide what is the molecular weight of the molecule, because on the basis of molecular weight we can exactly say the number of units which are present, the glucose units which are present in this molecule. Now, moving further, to know the number of glucose units present or the molecular weight, although we say that it is not soluble in water or normal organic solvent, had it been like that, we could have easily understood by depression in freezing point and then elevation in boiling, depression in freezing point, or elevation in boiling point. That would have given us an idea that what would be the molecular mass of the polymer. Now, when it is not soluble, it does not form a complete solution. We cannot, determine the molecular weight based on these physical parameters. Then we are using the chemical parameters to discuss about the molecular weight. One of the important method that has been used is Howard methylation method. In that case, if we are using the methylated uh, methylated cellulose, methylated cellulose, as you know that we are having now cellulose, and when we say methylated cellulose, all of the free hydroxy groups that have been converted into ether linkage OCH3 methyl group has been added there. OCH, all of the free groups, none of the hydroxy group is free in this case. And when we are doing the HCl, we are treating it with dilute HCl, we are getting 2 3 4 5 2 3 4, sorry, it is not 5, it should be 2 3 4 6 tetramethyl D glucose, and we are getting 2 3 6 trimethyl D glucose. So these are the different units, different forms we are getting here. So when we say that 2 3 4 6 tetramethyl D glucose and 2 3 6 trimethyl D glucose, and we are confirming the estimating the percentage of these two molecules, we can say that based on this, as we said already, that is around 0.6% only, and this one is around 90% only. It has been found that around 100 to 200 units having the molecular weight of 20,000 to 40,000 are, the molecular weight of this cellulose molecule will range from 20,000 to 40,000. So the range is basically based on the number of n molecules, the number of cellulose units, or the number of glucoses which are present in this. So we say that it is around 100 to 200 units. Another important method which was used to determine the molecular weight was periodic oxidation method. In periodic oxidation method, we are using the cellulose that is not methylated, that is a free, the only cellulose, not the substituted cellulose, free cellulose, where we are free hydroxy groups. We are having free hydroxy groups that is treated with sodium periodate to get the final products. As in my previous video, I said that the sodium periodate has the main character that the vicinal diols are oxidized in this, and they are converted into acid. And if there are, like in that video we already knew that if there are three diols which are on adjacent carbons, then there will be the loss of formic acid also, HCOOH, and there will be the formation of two aldehyde groups anyway. When this has been used, the method, it has been found that from reducing side, 2 formic acid, and from non-reducing side, since in non-reducing side you can have, again we have 1 2 3, they are on adjacent carbons, so we are having one formic acid molecule which are present there, and one aldehyde, formaldehyde molecule has been produced. So estimating this formic acid using the estimation methods, on the basis of estimation methods, it has been calculated that around 1000 glucose units are present in the cellulose, around 1000 glucose units. But this method has found that it is not an accurate method because of the presence of over oxidation. Because there is an over oxidation, based on the over oxidation, it has been shown that the method is not a reliable one. The over oxidation has been avoided by modified method. So in that case, there was a cellulose. The cellulose units were reduced by using sodium borohydride, sodium boro NaBH4, and then This sodium borhydride, when it was reduced, it reduces the terminal reducing units. Whichever the terminal reducing units are there present, they were reduced, and then it results the product is subject to oxidation with periodate, and in that case, a suitable pH was used for this oxidation, and there occurs a rapid selective oxidation in the terminal glycerol group, and thus over oxidation is avoided. So by using that modification method that was given by Belcher in 1965. So what they did, Belcher did, is that he has used sodium borohydrate to reduce the terminal reducing units, and then at suitable using the suitable pH for the oxidation, using suitable pH for oxidation, and that oxidation was again done by the sodium per iodate per iodic acid NiO4 NaIO4, and then it was it was only the glycerol group that has been reduced. So that reduces, that over oxidation has been overcome by this method, final method. So because when we say the over oxidation, you can say that even all these hydroxy groups, they have been oxidized in this. So from this, now it was approximately, the chain length has been found that it is approximately 1000 glucose units. So thus this confirms the overall structure of this cellulose molecule. Now when we say the physical methods, some physical methods have also been used to elucidate the structure. Like we said, as we have already discussed, that there are two types of molecular weights. One molecular weight is calculated by osmotic pressure, and that molecular weight is known as number average molecular weight, Mn. And then again, another one is viscosity, determined by viscosity, ultracentrifugation, and sedimentation. That is molecular weight, average molecular weight, MW. So they, all the four methods have been employed for identifying the molecular weight of these molecules, and it has been found that uh, you know it has been found that the molecular weight is around 300,000 to 500,000 units, corresponding to a chain length of around 20,000 to 2,000 to 3,000 glucose molecules. We know that the importance of molecular number average molecular weight and weight average molecular weight is that it helps us to decide whether the polysaccharide which is present is in the form of monopolysaccharide, or it is a homopolysaccharide, or you can say homopolysaccharide or heteropolysaccharide. And if number average molecular weight Mn is equivalent to Mw, weight average molecular weight, we say it is a homopolysaccharide. So this has been method, and in this case again we can say that there is a variation, that it is from 200 to 300 units. So the variation is due to the difference in number of n units, as we said that in previous. Again we said that n, that is the number of glucose or cell biose units which are present there. Based on these, we say that the molecular weight differs, and it has been found that actually this molecular weight, that is around 300,000 to 500,000, is the molecular weight of unreacted native cellulose. That is the cellulose we are getting, the raw cellulose we are getting from the pulp of the tree. And we are saying that if it is purified, or if its derivatives are used, then the value of n is less. This value decreases, and the molecule, because we already said that when we are doing the purification, will be some degradations, and we are getting the molecular low molecular weight uh, cellulose. And again the value of n also depends on the source from which the cellulose has been obtained. So based on these two factors, we say that the value, now its value ranges from 2000 to 3000 units also, and it depends on where from we are getting the cellulose, and the technique we are isolating it also, and whether the cellulose which has been obtained is in purified form, or it is in a raw form. Then as we said that X-ray, they also helped us to get the structure of the cell, and it has been found that it is having a monoclinic structure. The cell is having monoclinic structure that contains four anhydroglucose residues parallel to the vertical, and thus with cellulose units each, 'at its corners and one through the center. And Along the B axis, it has been found that the glucose units are firmly held together by beta D group. That means the linkage from X-ray, when we say that X-ray, it shows that the linkage, that is the 1,4 linkage, it is beta in nature, beta D group linkages. So from the beta group, beta linkage has been confirmed by the formation of cellobiose, and also from that was from the acetylolysis, and it has also been confirmed by the X-ray studies. And again, since I said that it is having a three-dimensional structure, it has been found that the along the B axis they are connected through 1,4 linkages. Then that is the linear way, that is like this. When they have been connected along the B axis, they are connected with 1,4 link. Then they have been along the X axis, they have been shown that the two links, that is one linear chain starting from reducing towards the non-reducing end, and another chain starting from reducing to non-reducing in an alternate direction, that is non-reducing on this side and reducing on the other side, that is an alternate way. So they have been found that they are connected through hydrogen bonds, that is O, H, and there definitely it will be the O here. Since we know that there are three hydroxy groups present on in each glucose unit, three hydroxy groups, so they are used for the hydrogen bonding. These two chains, they are connected through hydrogen bonding. Then along the z-axis, along the c-axis, they have been also find that there is another chain that is along the c-axis. That chain has been found associated, they are connected with this through weak van der Waals forces. So the three chains are connected. One is along a B axis, one is along X axis, A axis, or one is along C axis. The one B and A axis one, they are connected through hydrogen bondings, and the one which is connected along C axis, that is connected with these two chains along with the weak van der Waals forces. So we can say that the three chains are connected to each other, two with hydrogen bonding and the third one with the weak van der Waals force. Thus this gives us a three-dimensional shape of the cellulose. Again, this shape, where we can say these two, the two linear chains, they form a structure, the chain layer structure. That layer structure is also important for the formation of the colloid. That layer structure is not possible if it is having a branched chain, and if that is not possible, then in that case the formation of colloidal solution will be it will be difficult to get a colloidal solution, and we may get a suspension rather the colloidal solutions. So that again shows that these chains are linear, but these chains, they are connected with each other through hydrogen bonding or through weak van der Waals forces. Thus we can say that the cellulose has an arrangement of combination chains and chain and layer lattice, we can say, because in three there are three chains in three lattices, and they are connected with each other, three axes, and they are connected with each other through hydrogen bonding or through van der Waals forces. So we say that the overall structure, that will be a three-dimensional structure, that is a chain and layer lattice. But when we say the structure of one chain is, again, it is linear, it is having beta linkages in it, and that chain and layer lattice arrangement, that is essential, accounts for various properties of cellulose, like I discussed here, that why it forms a colloid. So this is how we can get the information about the structure, the character, the chemical structure, the elucidation of the structure of the cellulose. Thank you for watching this video, and for getting more information about more videos about the chemistry, do subscribe. Thank you.